In Forthic, there is only one kind of thing, a word. If you want to execute a function, you run a word. If you want to get the value of something, you run a word. If you want to define a new word, you run a word. Words in Forthic are like atoms. To go deeper than a word, you need to go subatomic and cross over into the host language. If words could be executed independently of one another, we'd be done. However, some words produce values, some consume them, and some do both. In order to manage these values, we need someplace to put them. The simplest place is a stack. A stack lets you push values into it and pop values out of it, just like a plate dispenser at a cafeteria. In our case, the values would be the plates, and Forthic words would be the ones adding and removing the values. It's easier to think about a Forthic stack if you lay it on its side. In this orientation, the contents of the stack mirror the Forthic code. Let's look at a simple example of a word that consumes values and produces a result. Consider the plus word. It takes two numbers and adds them together to produce a sum. We can document the behavior of this word using something called stack effect notation. To the left of the two dashes is the state of the stack before the plus is executed. To the right is the state after. The numbers are a kind of literal word that can push their values onto the stack when executed. Strings, dates, and times are other kinds of literal words. Strings use a Python-like syntax. You can have single quoted, double quoted, and triple quote variations. Comments are technically literals too, but they don't do anything, so they don't change the stack when they are executed. Comments start with a hash character and go to the end of the line. Anything that's not a literal will have been created by a Forthic word, and these values could be anything that the host language can manipulate. However, there are three kinds of values that appear in almost every Forthic application. These are arrays, records, and variables. An array is just a list of values. We create an array using the left square bracket and end it with the right square bracket. A record is an object that has keys and values. We construct a record by passing an array of key value pairs to the rec word. Variables are created by passing an array of names to the variables word. A variable is kind of like a literal. It pushes itself onto the stack when executed. However, there's a difference between a variable and the value of a variable. The value of a variable can be set using the exclamation point or the bang word. And we can retrieve a variable's value using the @ word. New Forthic words can be defined in terms of other Forthic words. Here's how we might define a word that doubles a number. A definition begins with a start definition word. This is a colon followed by a space followed by the name of the word being defined. When executed, it puts the interpreter into compile mode. When in compile mode, words are added to the current definition as they are executed. When we hit the end definition word, that takes the interpreter out of compile mode and registers the new definition. Words defined this way are no different from any other Forthic word. Definitions should ideally be one line long. This makes it easier to figure out what they're doing. Every definition should also endeavor to raise the level of abstraction. Ultimately, we'd like to get all the way up to the problem domain. Definitions at this level can be validated by the end user from their own perspective. We use modules to organize our words. There are 3 kinds of modules. The first is the global module, which contains words that are available in every Forthic application. The second is our app module. This holds our own definitions and the variables that we define. The third kind of module are the built-in modules. These hold words that are implemented in the host language. Words from these modules can be added to the app module using the use modules word. Built-in modules allow Forthic to access anything the host language can. The official ones are documented in the Forthic repo. At this point, you may be asking yourself, why use Forthic? What's the benefit of this? It looks very different from what I'm used to, and I don't see why I would use it. Well, there are a number of reasons. One is that Forthic code flows in the direction of the logic that it implements. Consider the case where you have an array of tickets and you want to select the unresolved ones. In Python, you might do something like this. So far, this looks fine. But suppose you want the assignees of these tickets. You might call an assignees function. It's a little bit more complicated, but it still looks okay. But what if you wanted the managers of those assignees? Then you might call a managers function. Now it's clear that the Python code is literally flowing backwards. You have to read this right to left, inside out. In Forthic, it would look like this. The Forthic words flow in the same directions as the operations. If we wanted to add something in between, like selecting high priority tickets, we would just add that word in the appropriate spot. Another reason to use Forthic is that it's easy to abstract code. Suppose we wanted to compose unresolved and high priority into the word urgent. We would just cut those words out, create a definition from them, and use it. There's no fiddling with parentheses or doing any fancy refactorings. The abstractions can be done quickly and surgically. Another reason to use Forthic is that it's extremely dynamic. It can be manipulated, constructed, and tweaked up to the very last moment. Consider the array 1, 2, 3. If the number 1 were already on the stack before we started, we could use the swap word to put a start array token just before it, and then construct the rest of the array as normal. Because we use words to do everything in Forthic, we can combine them in powerful ways at any point in time. But perhaps the most important reason to use Forthic is that its words are naturally point-free. By this, I mean that you don't explicitly specify arguments. Arguments come implicitly from the stack. This allows us to view the execution of words in every Forthic application as a series of transformations. Once we view Forthic code this way, we can use category theory to analyze and design Forthic words and programs. This is what takes Forthic from being a curiosity to something profound. In our next episode, we'll start doing some actual Forthic coding by going over an example that does some interesting things with Jira data. Hope to see you then.